Welcome to The Explainer. Today, we're unpacking something totally mind-bending, how ancient mathematical rules evolved into profound spiritual architecture, and how that very same architecture is now shaping our eco-friendly future. If you think geometry is just about memorizing formulas from a chalkboard, well, you're in for quite a ride. We are going to explore how the math of the ancients literally maps out the cosmos.
Think about this for a second. What could possibly connect a 4,000-year-old clay tablet to a massive, modern solar-powered temple? It's a pretty wild question, right? But it bridges millennia of human ingenuity and our relentless pursuit of universal harmony. It turns out the way we used to calculate the area of a muddy field and the way we build sacred spaces to capture cosmic energy, they are deeply, intimately connected.
To make sense of this all, here's how we're breaking it down today. We'll start with the birth of practical geometry, then move to chasing the value of pi. From there, we'll dive into Indian sacred temple geometry, explore universal sacred geometric patterns, and wrap up with green temples for the future.
Let's jump right in. Part 1. The birth of practical geometry. Rewind with me to the ancient world. Back then, geometry wasn't some high-minded spiritual pursuit. It was pure, absolute survival. Construction, commerce, making sure your farm wasn't washed away by a flood. In fact, the Babylonians were calculating the areas of rectangles and circles way before the Greeks ever stepped onto the mathematical stage. Around 2100 BC, they were scratching basic geometric relationships onto clay tablets just to handle practical, everyday financial calculations. It was a world of crude approximations and trial and error, driven strictly by the need to measure land and navigate the stars.
And that raw need kicked off a global obsession to find the exact ratio of a circle's circumference to its diameter. We know it today as pi. Around 2100 BC, the Babylonians simplified it to just 3. Fast forward a bit, and the Egyptians bumped it up to about 3.16 in 1650 BC. Jump to 287 BC, and Archimedes calculates strict bounds for it. And much later, around 430 AD, the Chinese mathematician Zhu Changji remarkably nailed it down to the fraction 355 over 113. It was truly a multicultural math race.
Which brings us to part 2. Chasing the value of pi.
This ancient pursuit quickly escalated into some staggering theoretical feats. Take Archimedes' method, for example. Remember, the guy had no modern decimals and no algebraic formulas to work with. So what did he do? He painstakingly squeezed a circle between polygons of 96 sides. He drew one polygon just inside the circle, another just outside, and calculated their perimeters to trap the exact value of pi right in the middle. It was an absolutely stupendous feat of both imagination and raw calculation stamina. No computers, just pure brainpower. And this shift perfectly highlights a massive historical pivot. We transitioned from the very physical, hands-on geometry of ancient times, literally having to draw 96-sided polygons, to the European Renaissance, which blew the doors open on a whole new mathematical world. Brilliant minds like Wallis and Gregory started using pure, abstract algebraic calculations and infinite series to compute pi. We moved from geometry you could physically draw on the ground to algebra you could compute forever in your head. So how does this math map the divine? Part 3. Indian Sacred Temple Geometry.
How did the strict, utilitarian logic used for dividing fields scale up to literally map the heavens? Well, when hardcore mathematics merges with deep spirituality, we get sacred geometry. Now, this isn't just about making a building look pretty. It's a profound philosophy that specific ratios, shapes, and measurements carry metaphysical significance. It leans heavily on fractals, patterns that repeat infinitely at every scale to create an undeniable sense of harmony and balance that mirrors the cosmic order itself.
There's a foundational Hindu philosophy that sums this up beautifully. Yatha pende, tatha brahmande. It translates roughly to, as is the microcosm, so is the macrocosm. It's the ultimate concept of interconnectedness. The idea is that any single, perfectly proportioned structure can fully contain the entire blueprint of the infinite universe. Basically, when you walk into a masterfully built temple, you're symbolically walking right into a miniature replica of the cosmos.
You can see this clearly in ancient mandalas. Take the Manduka mandala, an exact grid of 64 squares, or padas. These were never meant to be just simple floor plans for the builders. They are highly sacred blueprints derived from ancient texts. The central square, known as the Brahmasthana, physically houses the divine energy, and every single stone placed around it is mathematically perfectly aligned to support that singular cosmic center.
We also see this divine math in mystical diagrams like the Sri Yantra. It's an astoundingly complex geometric engine of spiritual focus. It weaves 4 upward-pointing triangles representing Shiva and 5 downward-pointing triangles representing Shakti. They seamlessly interlock to create 43 smaller triangles, all radiating outward from that absolute cosmic center, the Bindu. It's literally math as meditation.
And when ancient architects took this 2D fractal geometry and built it into 3 dimensions, it became the towering shikharas, symbolic mountain peaks stretching into the sky. If you look closely at structures like the Kandariya Mahadev Temple, the main central spire is surrounded by smaller replicas of itself, which are then surrounded by even smaller replicas. The pattern cascades down, self-replicating over and over, a perfect architectural mirror of a self-replicating universe.
Moving beyond India, let's look at Part 4, Universal Sacred Geometric Patterns.
Because this pursuit of cosmic mathematics, it definitely isn't limited to a single region. Human beings all across the globe have identified and revered these exact same geometries. From the golden ratio, phi, that effortlessly dictates the spirals of a seashell and the sweeping arms of galaxies, to the overlapping circles in the flower of life, to Plato's Platonic solids. Cultures globally locked onto these specific shapes because they intuitively represent the seamless, underlying harmony of existence itself.
A fascinating, tangible example of how this geometric impact carries forward is the circular Ekatarso Mahadev, also known as the Chusath Yogini Temple. The perfect circle and central point are deeply linked to Shiva in Hindu philosophy. But here's the truly amazing part. This stunning piece of ancient sacred geometry directly inspired the design of the old Indian Parliament building. The very same shapes that ordered the ancient spiritual world went on to physically house a modern democratic one.
Which leads us perfectly into Part 5, Green Temples for the Future. That bridge to the modern world brings us to today. We are taking that ancient architectural reverence for cosmic balance and translating it directly into macro-level ecological action. Because these spiritual centers are such profound symbols of faith, they attract huge, massive gatherings of people. Under the Viksit Bharat 2047 vision, these places of worship are being totally transformed. The logic is simple but powerful. If a temple represents the harmony of the universe, it absolutely must operate in harmony with the local environment. So, they're being leveraged to teach and practice crucial environmental sustainability to millions of visitors.
And the scale of this effort is wild. Just look at this number, 8 tons. In India right now, a brilliant startup named Fool prevents 8 tons of floral waste from being dumped into the Ganga River every single day. Instead of letting those sacred temple flowers rot in the water and ruin the ecosystem, they are beautifully and geometrically recycled into natural incense and fully biodegradable packaging.
So what does this actually look like on the ground? The actionable steps to greening these sacred spaces are incredibly practical, bringing us full circle back to the utilitarian roots of ancient mask. It includes recycling organics, harnessing solar energy for power, mandating massive rainwater harvesting systems, and planting native species. In fact, there's a specific goal to plant native trees, like the neem, to achieve a 1:7 human-to-tree ratio. This allows these massive sacred spaces to act as essential breathing carbon sinks for the planet.
Which brings us to our ultimate takeaway. We've seen how crude, muddy land measurements evolved into a theoretical quest for pi. That math then built fractal, sacred temples, which are now driving incredible modern eco-sustainability. So, as we wrap up this explainer, I want to leave you with a question. If ancient mathematics can be used to blueprint the cosmos and heal the Earth at such a massive scale, how will you use those principles of balance and harmony to design a sustainable space of your very own? Something to think about. Thanks for learning with us today.